so that everybody will be on the same page. So let's, in the next 3 minutes, we are ensure that all of us have gotten the data so that we can start. So I've written down the things we are to do today so that I will not miss out on any. So follow it. Now, what to do so that we won't miss anyone. The first thing is dot followed by this, followed by this, followed by one after the other. So, have we all gotten the data? So we are good to go. Okay, we can start now with the opening prayers.
Let's rise up to pray. Eternal Rock of Ages, we thank you. We bless your name for yet another day. We thank you for all that we learned yesterday. And we thank you, Lord, for how far you've gone with us. Father, we commit today into your hand. We ask, Lord, that you take perfect control in the name of Jesus. We receive sound mind in the name of Jesus. And we pray, Lord, at the end of today, we will have focus to glorify your holy name. Thank you, blessed Redeemer. In Jesus' mighty name, we have prayed.
Thank you. Okay, let's have our seats. Okay, you've downloaded it. You've downloaded the data. You can email it to him. I send it. Okay, she has sent it to him. Okay. Okay. So, okay. I want to start today. So I don't want us to miss on anything so that I have written them down. So I'll be following it one after the other. So the first thing we are going, this is data of is survey and so the data have 11 variables. You have gender, height, weight, age, insomnia. If you check the insomnia, you saw the value. 0 means absent. 1 means present. So, you see the data of marital status. 0 means single. 1 means married. You saw the data of gender. 0 means female. 1 means male. Okay, sorry. Yeah, 1, 2, sorry. Then this is for anxiety group. We have mild, then to severe. So we are trying to know the number of hours. So with this data now, we use it today and tomorrow, and I'll still give another data for handover to test a lot of hypotheses. Then outcome, fail or pass. So based on what I wrote today, the first thing we have to do is scatter dots, because scatter dots is a pointer to the correlation. You know, scatter dot or scatter plot. So what correlation does is to show the nature and the strength of a linear relationship between two variables. Most times it is a bivariate analysis. That is, you have X and Y. So let's go to our graph. So this time we select weight, height, because those graph, scatter dot, single scale, simple, defined, then your X or Y is irrelevant, whether you put height here or weight here. Okay. So let's do it slowly and easy. You go to graph, you go to scatter. No. You go to graph. Yes, it's a pointer to correlation. That is scatter plot. So what correlation does with the scatter plot or dot, you can see the behavior. You know, whether it is, there are three instances. It's positive correlation when both are increasing or decreasing together. It is zero correlation when there appear to be no relationship between them, and you have negative when one is increasing. Yes. No, not that, sir. No, not that. Go to graph. Scatter dot. Yes, simple. Then defined. You can click OK. Let's see the result. Let me see what. We use height and weight. Anyone? Height. Yes. Yes, okay. Yeah. So now, when you are done, you click OK. So what can we say about that plot? So with this scatter plot, height here, weight here. Height here, weight here. Height, yes, sir. Weight. So with that now, click OK. So that click OK. So why I keep left it so that people can still look at it. So, you know, scatter plots will not actually give us a quantitative value that we use for analysis. It's just a graphical. It depicts the nature. But when we now want to establish to know if the nature or the strength. That's why we need the correlation coefficient. So this is the scatter plot. And you and I know in our classical physics experiment, we usually generate data like this. I remember secondary school or physics practical. So it do not ask you to use, draw a line. Sometimes you see the line like this. If it is current and voltage, okay, or current and resistance and the rest. Hope we can now do scatter plots very well. Yeah. Yeah, that's what I'm saying now. It is, we can conclude when we now find the correlation coefficient. That one will give us a value and a p-value that establish relationship. Yeah. Yeah. And that's what I'm saying. That by the time you look at this scatter plot, it might not looking at it, it appears that there is no relationship. Or can you say that all of them are increasing? Remember, if it's physics practical, what we do is they now ask you to draw a line that appears to capture most of them. Remember that time? You can just be, if you notice this, can be 1, 2, 3, 4, or that's the way you draw a line. But by the time we now use correlation coefficient, we now say for sure the next. The line of best fit is regression. You know. Hmm? Hmm. Yes, I couldn't get data that we show everything descending like this, like or anything increasing like this. So this is why we need correlation coefficient, because I can give different value. I can draw a line and say, okay, my own line is like this. That means they are decreasing. I can draw my own line straight like this, say there's no relationship. Someone else can draw like this. But when we now use software to compute, so this is the limit. When you are teaching student correlation, first of all, say this is like the freehand just to draw. And then why the software now perfect it by computing the relationship. Okay. Are we good to go? So later we will. Notes are there. Huh? Okay, close. Go to graph. Legacy graph. Scatter dot. The first one, define. Put okay, weight and height. Hmm? Yes. Okay. That means something is wrong with the data. Can you just delete this and download the data again? Huh? From your email. So it's obviously something that the way it is from the email, just download it again. So let me check the second thing I have here. Yeah, histogram. So we are going to plot the histogram. Yesterday, we plotted only bar chart and pie chart and line graph. So today we are going to look at histogram with the normal plots there. So let's get started. Still go to the graph. It's the same thing I told us yesterday. And then go to histogram. And then move the height there. Okay. Then click display with normal curve. Let it be like this, height or weight, displays with normal curve. You know, normal distribution, wants the observations to cluster to the center. Then you click this. Then okay. Scroll down. Then when you are done with that, click OK. And then we see the result of the histogram. No, nothing. Just click OK. Can you change the color of the bar? Height. Yes, put height. No, for this value. Display normal color. Okay. Help me change the color of the bars. What is that normal color telling us? It's part of the graphical. Want to test normality. Okay. I can change the color. So, are we all there? Wow. Okay. Practice one. Practice test one. I use height. You can use weight. So try weight. For histogram, try weight. Try weight. We'll confirm it when we now do normality test. We are going to, it's part of the thing I wrote down that we are going to do normal test. Yes, this one you can't say for sure that is normal until you do a confirmatory test. It's just like that scatter plot. You can't say, okay, that scatter plot is positively correlated until you now compute the value. Have you gotten the data? So you've done it? Okay, for wait. This doesn't look like normal at all. So you should be jotting down the steps so that when you are at home or anytime, you just do it and get the result. They will. They installed it here. They can give to you. This lady has it. This guy has it. Maybe ask her how she got the software. So, normality test. So, this is the second thing we've done today. And histogram is very important in real life. Bar chart is for discrete data. If you notice, I didn't say histogram for discrete. I limited it to those that have interval. Yes, ma'am. That's why I said this is like a freehand method. We can't actually graphically, all of us can give different. If I ask us to plot this graph, assuming if we have sheet of paper, we are not likely to get the same. Some people will choose 2 lines, some people will choose 3 lines, some people will say, okay, the best fit appears to be decreasing. But later, we now do correlation coefficient with that same data. That will now give you the exact value, whether it is increasing or decreasing or no relationship between them. Yes. Yeah. You can't confirm until you have the quantitative data that supports. Yeah, this is just to graphically depict what you might feel. It's just like you remember when we did physics practical in secondary school. They were asked us to plot 3 or 4 graphs. They now ask you to use 1 line. So obviously, all of us might not get the same slope. Some will get 0.94, some will get 0.99. But actually, maybe the slope is 1. You understand? So now, what this correlation does is to give us the exact slope, irrespective of how all of us look at it. So if not drawn the histogram. Okay. 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 Thank you. Any more questions before we go to the third thing we have today, which are normality tests. Why is normality test important? As I said in the first class, most of the analysis you do will depend whether the data is normal or not. Remember, statistically, every distribution can be approximated using normal distribution at large sample. What this means is that it approximates. You had the word approximate, not the exact, approximate. In statistics, we have what we call the central limit theorem that ensure that the mean of random observation at large sample, if the samples are not large, forget it. So no matter the distribution, at large sample, the mean approximates to that of the normal distribution. That's why you have the central limit theory. There are a lot of things, Jensen inequality, weak law of large number, small law of large number, and the rest. But those are statistics. So we are not going into that. So let's look at normality test. So this is what we have here for normality test. We now move over to normal transformation. How to transform a variable from normal, that's not normal, to normal. So we are trying to check if this height and weight are normally distributed. So, and how are we going to do that? SPSS will give us two options. Anderson-Darling and Komogolo-Simulon. But in real life, there's one they call the Agostino's test and then Jackie Bella. But SPSS doesn't do the Agostino test and Jackie Bella. So let's check. Okay, we'll go to analyze. We'll go over to descriptive statistics. We'll go to explore. You have analyze, descriptive statistics, explore. So we move only the height there. So we after the height, we'll come back later and check the factor list. That is where we have one variable, like we say this height now is the male normally distributed or is the female normally distributed, the data. Then you go to statistics. Okay, we'll come to this later when we'll discuss on how to detect outliers in your data. So go to plots, and most importantly, put normal plot with test. Click normal plots with test. This is very important. Normality plots with test. Then okay, continue. And then okay. So this is the result it will give us. But this is my emphasis is here. Okay, this is what we call the Komogorov-Simonov and Shapiro-Wilks. Okay, Anderson-Darling is not here. Komogorov-Simonov. And what is it telling us? The p-value there is 0.199, which means that the data is what? What does that mean? The p-value there is greater than 0.05. No, this is, let's brainstorm. What is the null hypothesis? Yes. Yes. That's true. Okay. Okay, let me start. Okay, 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 all right. Okay, okay, okay. Yes, calm down, calm down. Let's calm down. Okay. 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 Okay, we will. Everybody will be carried along. Okay, okay. In normality test, the null hypothesis is that that variable, the distribution, is normally distributed. And what do we mean by null hypothesis? Is what? A statement we want to disprove, right or wrong. So we have null hypothesis and alternative. Yes, that is the null here is that the data, no, it is normally distributed. Then the alternative means that that distribution, what, is not from normal, but we can't pinpoint whether it is uniform or whether it is, you understand, binomial. But with this p-value, note, is the p-value. The p-value here, we have already defined the p-value as p 0.05. Any value less than 0.05 means we now accept the alternative, which is that is not for normal distribution. But when it is greater than 0.05, of which in this case is greater than 0.05, we now accept the null hypothesis that that distribution is for normal distribution. Is that understood? But what it won't tell us that we don't know the distribution it is if it is not from normal in the case. So I don't, but the only thing now is that when you accept the null hypothesis, that means that distribution is for normal distribution. That variable in this case is normally distributed. Okay? So what you look at is the value of that p-value. If this p-value is less than 0.05, that means that variable is not from normal distribution. Otherwise, it is from normal distribution. So both tests, SW and Kolmogorov-Smirnov, proved, look at them, 0.522, 0.199, that the variable, that is the height of the respondents, are normally distributed. So any more questions? So there are other things that we have Anderson Larry, we have Jackie Bera, and the rest. So with this now, we can confidently apply t-test here and another, as if we want to do something. Okay, but tomorrow we'll be talking of non-parametric text. What if the variable is not for normal distribution and we can't use t-test and we can't use another? What can we use? Okay, okay. That means we switch over to median analysis. That is Mark Whitney's and Chris Kawali's test. So we see that everything about tomorrow will be ANOVA, both parametrics and parametrics. Okay. So practice. Yes, yes, check whether it's for normal. So for this assignment 2 today, we've done height. Can somebody shake weight to know if it is? And then just call me the p-value. Yes, for normality, follow the same step. Most times people prefer Shapiro-Wilks. Yes, because you will have some instances, one will be significant, one will not be significant. So when that happens, you go with Shapiro-Wilks. You know. So when that happens, see, let me say something. I read it, I think 2 weeks ago. if you have this situation, because SPSS don't give the highest test for normality is, there are two tests. We call it the Augustinus test. So that is a confirmatory whether that distribution is normal. Okay. So when when these two cannot give you what you want, you look for the Augustino test. Agostino. The apostrophe Agostino. Yes. You go with Shapiro-Wilks. It's a stronger than Augustino. But I thought the best is the Augustino, but SPSS can run the Augustino. Yes, I run some, I've done some tests. I have done the Augustino, I've done Jackie Berra. You can use R. R software is what you can use. Or you can check online, that is this man, Wessa. Is it .net? WESSA.net. You can, have you seen something like that? Yeah, Wessa.net, you can run the test there. It's also GUI. Yeah? Hmm? Hmm. You go with Shapiro-Wilks, it's stronger. So let's check for weight. Yeah. Yeah. Yes. Yes, still testing. So let's do for weight, and let's do for exam score. Weight. But when you do for weight, please, can someone call, what do you have as the p-value for chromoglobin for weight? And then what of Shapiro-Wilks? Okay, that means both of them are normally distributed. Hey, yes. No, weight, not age. Weight. Weight then. And you can do height. Yes. Do exam score and anxiety score. Statistics. No, plots. No, you make click here, both. Ahead. Okay. What do we have for p-value? Okay. Some people are still there. Let's give them some time to get it done. Yes, ma'am. Will. It's computer using different formula or different formula. Okay. Please, let's check the exam score. I'm interested in the exam score. 0.83. 0.08, which is greater than 0.05. That means it is also normally distributed. Then finally, let's look at anxiety score. Okay, let me do it so that we can look at it. Is it for exam score? No, we are not doing for age. Obviously, age will not be normally distributed. No, age might be. No, I think those ones that are 1 to 01. Okay, exam score. So in this one, we go for exam score is not normally distributed. So SPSS doesn't run the Augustino test and Jackie Bella test. Okay. So those tests are the confirmatory tests. They are high a part of it. So I don't know, unless it can be through coding, but I do it using R. Yes. And that's why I'm saying, I said it several times. I say, when there are conflicts, we go with Shapiro-Wilks because it's a stronger test than Komogolov-Simonov. So when there are conflicts, you go with Shapiro-Wilks because it's a stronger statistical test than Komogolov-Simonov. Yes. And it's okay. I understand what you mean, but if you notice, I'm silent about kurtosis and skewness because of what? I understand the nature of the class, because that Jackie Bella test is a test of kurtosis. That Augustino test is a test of skewness. So I am doing things that everybody here, irrespective of your field, can easily run and interpret. You understand? You simply interpret it. Okay? So the order is there. If both gave you the same thing, fine. But if there are conflicts between Komogolov-Simonov and Shapiro-Wilks, you just go for Shapiro-Wilks. Simple. The skewness, kurtosis, notwithstanding. Is that okay? So it will be easier to interpret. And then if you are writing papers, you look for sure to back it up. So let's check. Go back to height. Yeah. Yeah. That's what I'm saying. So we, before, if it's like we want to run t-test, for example, we no longer use t-test there. We now use man-witness, which is a test for median. Then if we want to do ANOVA there, we no longer use ANOVA. We now use Kruskal-Wallis. So we'll see all those things tomorrow, ANOVA and Kruskal-Wallis. Okay? Because most time I'm surprised. Okay, let's continue. I want to check between genders. So, what am I trying to do? I want to compare the exam scores for the gender to know if maybe for male are normally distributed and female are normally distributed. So do that. So you will repeat it for all the cases. So from exam score, we do for anxiety score, the height, and the weight. So let's do that. Let's have one for exam score. So you click. Okay. Okay, this is the test. So this is funny, isn't it? We have issue in one. So that's why it is good for labeling. If you notice, if I didn't label 1 equals to female, what the computer will bring out there is 1, 2. If you didn't assign values for the gender, you just bring 1, 2. 1 there is male, 2 there is female. So if it's like paper publication, you can now say, okay, for this is happened, for this is what happened. So what we do is to, decompose the exam score into male and female. So let's decompose that same exam score into marital status and then into insomnia. Let's do that. Let's repeat for this exam score into marital status. Yes. What is suggested that the implication is based on the response. This is an exam score. There is no, let me explain. Let me explain. There is no issues there. It's just like, in statistics, he said this is the lower bound of the true significance. In statistics, the ethics there is to report the data the way it is. So in this one, this is exam score. What does normality means? Let's start from there. It's what we say every day on the average. Let me give a typical example. You have the average life expectancy. So in Africa, most countries in Africa have low average age life expectancy compare with countries like Japan, Norway, Canada. So what it means is normally it's expected that that's when the person will die. You understand what I mean? That is, I used a typical example everybody know about average life expectancy. So average life expectancy, that it is expected that on the average, this is when the person will die. But that does not mean that the person will die. Because what you come by average is that when you take all the observations divided by the number of the observations, you come up with an average. So when somebody deviates from the average, you understand? So when somebody deviates from the average, and somebody, if average life expectancy is 54, that means you have maybe plus or minus 3 or plus or minus 10 standard deviation. That means in that country, most people will die between 44 and 64. That's what it means on the average, between 44 and 64, plus or minus 10. You understand? So that is what we mean by normal. Normally, this is how it's supposed to be. But when there is a deviation, that means it's no longer normal. For example, what my friend there said concerning COVID-19, it's obvious that maybe COVID-19 has decreased. No, the average life expectancy, maybe from 59 to 58 or 57. So that is what we mean by that normally. So it's not that it's issue. So here, it means that if people, like, sometimes I analyze my students' score, especially for exam over 30. I will look at it, okay. If I didn't give them much assignment, that means most of them will fail. So if a test of 30 and the average is 10, what is it telling you? That you will have a lot of casualties. So what I do, I can give the third test, I give 4 more assignments to increase that average, maybe from 10 to 20. So that I know in the exam, you just, anyhow, 25 over years with normal distribution. What then? I'm coming, sir. What you now call skewed. Anything that is skewed is no longer normal. Let me give you an example. You conducted a test and everybody is having 10 over 10, 10 over 10, 10 over 10. There is no 9, there is no 8. So if you draw it, it will go like this. So, but normal means everything appears to cluster at the center. That is normality. Maybe in the test of exam of 70, the average is like 50. That means most people score around 50. You can say, okay, 50 plus or minus 10, maybe the standard error. That means most people in that exam score between what? If it's 50 minus 10, 40, 60. So that means if I take, that is, maybe say 95% or 60%, or 90% of the students score between. So in that aspect, you can able to see what you are going to do next, how to detect outliers. You can be able to say, okay, when you plot it, you will see detail. You see outliers. Maybe a student score 1 over 70. Another one score 69. So that 69 appears to be outlier on this side, where the person that score 1 outlier on this side, while most of them seems to cluster at the center. So that is normal. So what it means for social sciences, if something is normally distributed, that means the responses are what? This almost the same. Yes. But when you choose strongly agree, not sure, disagree, strongly disagree, and most people are choosing strongly disagree, that means it's no longer a response. All of them have shifted to one side. But if it is normally, everything appears to be different. Is that okay? Yeah. Mm.
Does it not have implications for all of us here now that when you mark, if you plot, I mean, if you try to test for normality, because if they are not normality, because there are people that, because there are some people, wait, rule that says nobody can get in. And if scores are normally distributed, there should be A, there should be some failures, and there should be a clustering of. So when you mark, and you violate that law, something is wrong somewhere. Either with the matter questions,
or with the student.
or with the student. And of course, if it is the student, very much according to management before that.
What he says is true, because I remember when I did masters at Unilag, there's one course we did, we call it Mass 805, Measure Theory and Integration. Lebesgue is a very horrible course. That course, there we wrote the exam. People that have abandoned masters 9 years, that is ordinary, we're supposed to be 60 in the exam hall. But that day, people that came to write the exam were more than 300. And that exam, the pass mark is 5%. Or 10%. It doesn't pass 10%. That means in that 300, only that. That means 270 will come next year to write the exam. The man is a professor. You know that one, you don't. That's the result. He will ask you. See, I've seen the guy will result to the floor. So please, that's one thing. Like me now, my result let me compare. My result is not because I usually come to 9%. And the least you could see there is 66% pass. And that 66 was when I started. Maybe you see all my courses, like anytime I'm presenting the result, they will say, Hilary, your result is not always normal. Because of what? My students, I will give them an assignment until they are tired. I will give them more than if you see what they do now in my department is that if a student fail, they will say, let's check Hilary's score. If the student fail, that means there is nothing you can do. They won't say anything. Okay. You won't. That is, if somebody fail my call, that means there is no more hope. that means there is no more hope for the person. Because what I do now, I'll make it easy for me. Sometimes, like if I give you my notes, if I give you my note of statistical inference to everybody here, just go with it 3 days. You can come and be teaching that course. When I'm writing notes, I'm writing as if I'm a student. I will solve it the way a student will solve it in my note. Like the course I call probability distribution is, I have 125 examples in that note. So you know what I do? Is from that place I will set the exam. Randomly choose 15 questions. Student won't know the one I will pick. By the time the person, I give them assignment on that 125 examples. So in the exam, they will say, you see, I've solved this thing before. Before you know it, all of them will pass. There is no way I will teach a student. If a student fail my course, that means there is nothing else the person will do. Because by the time you solve 120 assignments and all of them are in the note, what I do, like if it's a course, like I will remove 2. Like maybe the one I solved in the note, maybe A is 2, B is 3. I will remove 2, put 4. I'll give it as assignment. They will solve, submit. And at the end of the day, I'll just sit down. I don't add 1 mark. I don't add half. I don't add 0.1 mark because I've already done my work. And the student will pass. The most important thing is for them to learn and pass. Yes. But ordinarily, a result is supposed to be normally distributed. Ordinarily. Yes. That means most people
You know, this result is a thing from a number of factors.
Mm.
Just imagine if you look at school like Harvard, entry point, there's the spread of the best and the best I know. So you don't expect them to have normal distribution.
Yes, I know. But that's why I'm doing what I'm doing, because many students come from different backgrounds. And let's not just deceive ourselves. Some of those students, their parents gave somebody money to write JAMB, write white. So when they now come to see you, they know that there is no option for them. They must learn it. Because we have zero tolerance for exam malpractice. So you now see the student, you now be surprised. You have A1 in maths and you can't differentiate y equals to a square. You know, that kind of things. You'll be puzzled. You understand? So in that case, you will give the student more assignments to do in order to pass. Yes. I don't know. You understand? So the results, like in our school since 4 years now, we don't add 1 mark to anybody. We present the result like that. I don't even give them area of concentration. By the time you do 120 assignments or 60 assignments, that's the all area of concentration. Yes. You know why assignment is good? Why assignment is good is that it's the same thing I'm setting for exam, but I won't tell them which particular number that will come out. So they will be afraid and read everything and understand everything. And then know theory.
No, I think it depends on individual. Some believe that give AOC, and they don't give AOC, and the exam will not mean. They will not know exactly what
you know the way they do. You know the way they do in some UK schools. In UK, when you start a class, the lecturer will give you like 50 questions with solutions. He has not thought. That 50 questions in the exam, he will randomly. That's why you see when people go to, you'll be surprised. Somebody that have 2-2, he will go to UK and became the best graduating student. B. U shape. You see, when you teach course and students are failing, it's adding negatively to your CV. No, if you see my CV, what will be seen 100%, 99.9, all the courses I taught since 2013, I have the percentage pass. And if you doubt it, you can contact CSIS in our school. Say, okay, I need the result of Hillary, this course, taking 2016. It will tally with what I wrote on my CV. How can I be writing failure on my CV? You want, I will write, I'm taking, my course is 40%. Who will give you the opportunity to come and teach this? But it's a theoretical, in real life, it's almost impossible to find a distribution that have the same mode, medium, mean. It's theoretically, but it can be close. Practically, it's almost impossible. But theoretically, we assume that normality means that the mean equals mode equals median.
Out of 29 students, 5 have to left. You know it's very issue. Yeah, we do. Because the standard is actually, but when I was reacting, 3.
It's a good result.
I was reacting. I didn't feel them. One of them. Sorry. One of them. when you specialize that and mention that God was very good, I think when normally when I was very myself, I gave the standard deviation and the mean and everything. After my explanation, it wasn't actually bad. Because I could prove to them that it was very normal. I took the normal description.
No, if only two fail in a class of 9, it's okay now. It's okay.
And it is that it was because I the college board we're not that bad. At the entire year. So you have to
There is one. See, what's your department? What's your department? No, what's your department? Okay, maybe you are not in sciences, like when you are doing physics, math, chem. You know, some courses that involve a lot of calculation. Students ordinarily, some fail, even if it's final year. Yes, I say courses that involve calculation. Ordinarily, some students are afraid of calculation. And they won't perform very well. And in that case, there's nothing you can do. There's nothing you can do. Will you write it for the students? Okay, okay. Okay. All right. Yeah, the class is online. The class is online. YouTube. Okay, let's continue. I want to check anxiety for gender. I want to know whether it is normally distributed for the male and female. So please, anxiety score, not anxiety group. Anxiety score for gender. I want to know which one is normal distributed or not. Yes, anxiety. Anxiety score. And then for weight, with talk of height, we need the normal distribution for the weight for gender. Yes. No, score, not level. No, not group, not group. No, that group is 1, 2, 3, 4. The other one. And that anxiety level. The one that have numbers, not the one that have 1, 2, 3, 4. Gender and then is it not here? Not anxiety group. Yes. 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 I think it's anxiety level and yes, because factor means that we are factoring gender. We are taking gender into consideration. Yeah, no, we're not talking about, we want to know whether the male are normally distributed or the female are normally distributed. But when we want to test whether they are the same, that's when we now use t-test. Whether the anxiety level are the same or different. Okay, that's where we now use t-test. Yeah, yeah. Normality test, normal transformation, square root method, normal transformation. So after this now, okay. Okay, none of them, all of them. Please check anxiety level and marital status. Which one is normally distributed or not? So later today, we'll now start doing t-test. One sample t-test and two independent samples, so that we're now trying to know whether they are mean are the same or different. Marital status. Yes, it's a top list. Okay. Okay. And also you check, it will present the descriptive statistics. Have you seen the descriptive statistics? It will now show the one that have the mean, the highest number of anxiety. For male and female, which one? Check the mean in the descriptive statistics. Eh? In this one. The anxiety, male and female, the mean. And the male. So that means the male have more anxiety than the female. Please check the descriptive statistics of the anxiety so that we know the male and female, which one have higher anxiety. Okay, check anxiety between married and single. Okay, or for So which one is higher, male? It's based on the data now. The data is okay. The male has more anxiety than the female. It's not supposed to be like that. When I no, I have to have no. You see, no, I know maybe this is maybe somehow the data is not that. Ordinarily, female have more anxiety. Why? Anxiety is what? An internalizing behavior. Why something like aggression is an externalizing. So women exhibit more internalizing behavior, while male exhibit more externalizing. Externalizing means when you are reacting towards the environment. But internalizing, when you don't want to, you are moody, anxious, you understand? So I think, check my status and anxiety. Is it anxiety and gender? Okay, female has more. Yes, it's okay. The result is okay. Yes. Ordinary female have more anxiety than male. No, the one that have the higher figure has more. The result is okay than the male. Yes. Okay. Let's check for marital status. Whether those that are single has more anxiety than those that are married. Let's check anxiety level and marital status. No, I mean marital status and anxiety. Okay. So can we interpret that the married had more anxiety than single? Is there an interpretation to that? Okay. Okay. Is there an interpretation to that marriage had more anxiety than the single? Ah!
Can we take decision on that without considering whether there is a significant difference between the two? And that's what we do. That's what I'm saying, because they are concluding. And I'm trying to oppose. That's what I'm saying.
We do a T test. T test is confirm. So we are just explaining for now. So we do a T test to confirm whether actually male. I like the response. Is there single? Don't worry. That's the only one. They were. Okay, let's look at the sensitive one, exam score and gender. So we don't want to conclude on that. Let's check exam score and gender to know whether the male or female, which one are more intelligent. Exam score and gender. Who score higher in the exam? Is it male or female? Yes. Ah! So we can confirm that the male are more intelligent than the female. Okay, we'll confirm. By the time we do T-test, we'll now confirm whether actually the male are. Okay. Or okay, yes. It's like a longitudinal data. Where maybe when. Okay. Let's. Okay, one house. Let's check whether. Okay, listen. Let's check whether marital status have effect on the exam. Let's check single or married. Which one that score higher than the other? To know whether marriage reduces exam score. Hi. Okay. Okay. Single is higher. And then married, how many? So that means marriage reduces exam score. Can we conclude? So marriages reduces score. So when somebody became married, this is funny. Yes. Yeah. Okay. Yes. This is funny. Okay, that's increasing the So school fees money. Okay, those one increases. Okay. Yeah.
So when you say not normal, it doesn't mean, there was time I think to reject it greater than
0.0. No, if it's you. No, which if it is less than 0.05, that means you reject the norm. That is not for normal. But what the SPS says, we don't know the distribution that it is if it's not normal. If there's any way to say, okay, it's not, since it's not normal, it might be gamma, it might be beta, it might be binomial. We don't know. Yes, which kind of data we have, whether it's normal or not. Okay, is it not time for break? So we'll come back by 11. Okay. Yeah. Thank you so much. So when we come back, we'll look at normal transformation and then we go on. We'll go to T-test. So we'll be back in the next 10 minutes.